Welcome back to The Explainer. So today, we're taking a strictly academic, highly rigorous look at one of the absolute biggest debates going on right now. We're going to scientifically dig into this widespread assumption that AI can already perfectly mimic human writing. It's time to separate the science fiction from the actual science. I mean, ever since ChatGPT dropped, this one single question has just completely taken over university classrooms, research labs, and newsrooms. The media has been in a bit of a panic, right? Hinting that we're all on the verge of being totally replaced. But if we step back and look at it from a strictly linguistic point of view, does AI actually write like we do? To really grasp the stakes here, just look at the real-world fallout. Back in 2023, the anxiety hit institutional levels, causing countries like Italy to temporarily outright ban the technology. And the core fear driving that? The idea that these AI bots can churn out text so naturally that they completely fool readers, essentially wiping out the need for humans in any language-based task. But here's the thing. Academically speaking, a lot of this fear has been fueled by anecdotes, not actual hard quantitative data. So, to get to the bottom of this, we're going to break things down into 6 parts today. First, the AI myth. Second, what are registers? Third, Bibber's 5 dimensions. Fourth, humans versus AI results. Fifth, detecting artificial texts. And finally, number 6, the future of writing. All right, let's jump into part 1, the AI myth, beyond the panic. To anchor our investigation, we are going to rely on a truly brilliant 2024 study by researcher Tony Berber-Sarhania, published in the prestigious journal Applied Corpus Linguistics. This study is a big deal because it fills a massive void in the scientific literature. Instead of just going off vibes or cherry-picked examples, it gives us a systematic, multidimensional comparison between AI-generated text and actual real-world human writing. So we're not guessing here. This is rigorous data science applied directly to linguistics. Moving on to part 2. What are registers? The key to variation. Okay, so in the world of corpus linguistics, a register is essentially this idea that how we use language naturally shifts depending on the situation we're in. Just think about it. You definitely don't use the same vocabulary, sentence structure, or tone when you're drafting a rigorous academic paper as you do when you're just chatting with a friend over coffee, right? The context dictates the rules. So if we want to truly test if AI writes like a human, we have to see if it can actually adapt across these different registers. A truly perfect linguistic machine would know how to read the room, so to speak. And Professor Sardina's study did exactly that. He prompted ChatGPT to generate thousands of words, intentionally divided across 4 very distinct registers. He asked for everyday conversations, academic article introductions, student argumentative essays, and news texts. Then, he took all of that AI output and compared it against massive established databases of real human writing in those exact same 4 categories. The goal was to see, point blank, if the AI could genuinely match human variation. Which brings us to part 3, Bibber's 5 dimensions, the methodology. So to compare these texts, the study used something called multidimensional analysis. This was developed by Douglas Bieber back in 1988, and it's pretty much the gold standard in corpus linguistics. It doesn't just, sit there and count vocabulary words. It tracks dozens of deep, underlying structural features all at the exact same time. Things like verb tense, pronoun usage, and passive voice. It's almost like taking an X-ray of the language. It calculates a mathematical score to see if a text is more involved or informational, if it relies on narrative, or if it's highly persuasive or abstract. So the researchers basically X-rayed both the AI and the human texts to see how their structural DNA actually stacks up. Let's look at part 4. Humans versus AI, unexpected results. Just look at this. It perfectly illustrates the issue. On the left side, when the AI was asked to generate a casual chat, it spit out this incredibly robotic, stiff sentence that honestly sounds like a formal job interview. Have you been on any other international trips in the past? But on the right, you have a real human transcript, and it's beautifully messy. It's full of pauses, hesitations, private verbs like wouldn't know, and this constant dynamic negotiation of meaning between the speakers. The AI just fundamentally doesn't know how to replicate the spontaneous, totally unscripted reality of an actual human conversation. And what's fascinating is that the math completely backs this up. Let's look at dimension 1, which basically measures how involved the author is versus how purely informational the text is. Authentic human conversation scored a massive 39.5. It's loaded with interpersonal interaction, first-person pronouns, you name it. But the AI conversation, it scored a measly 20.9. That is nearly half. What this shows us is that the AI is just really poorly designed for spoken grammar. It's trying to generate a casual, friendly dialogue while using the rigid, highly informational rules of written text. And honestly, these structural flaws just cascade across all the other dimensions too. The AI lacks natural narrativity. In an academic setting, it completely fails to make proper explicit references to outside information. In student essays, it totally misses the mark on tone, completely losing the markers of natural persuasion. And ironically, it attempts to be super abstract and theoretical when it's supposed to be having a casual conversation. It's basically like the AI is trying to wear a formal tuxedo to every single linguistic event it goes to, completely blind to the actual nuance of the occasion. Check out this wild failure in the academic register, specifically for chemistry. When prompted for a scientific introduction, the AI tried to sound super sophisticated and just generated this poetic fluff. I mean, interweaving itself in the tapestry of scientific exploration. Come on, no serious scientist actually writes like that. Meanwhile, the human text on the right cuts straight to technical precision, which consists in the permanent CO2 storage. The AI gets so lost in trying to sound smart that it completely fails the actual function of academic writing, which is to provide precise, explicit data. All right, part 5, detecting artificial texts, the numbers. So the researchers took all these mathematical dimension scores and ran them through a discriminant function analysis. Basically, they asked an algorithm to fly blind and try to separate the human text from the AI text based purely on these hidden structural X-rays. And the results? Across all the registers combined, the model correctly identified the AI-generated text with a really impressive 79% accuracy rate. As it turns out, artificial intelligence leaves a very distinct, highly measurable fingerprint in its syntax. But brace yourselves for this next data point. When the researchers isolated just the conversation register, the ability to spot the AI's fake text skyrocketed to 95%. 95%. The artificiality of AI dialogue is just so glaring, so completely stripped of any authentic conversational dynamics or interpersonal involvement that detecting the fraud becomes incredibly simple math. Think about that. The chatbot was literally designed to chat, yet from a scientific standpoint, casual conversation is its absolute greatest structural weakness. Which brings us to our final section, part 6, the future of writing, conclusions. This rigorous scientific exploration reveals a few pretty fundamental truths. Right now, AI has absolutely no real register awareness. It just does not comprehend that language has to organically shift to match the context. Instead, it plays it incredibly safe, leaning way too hard on a formal, polished, information-dense style for literally everything it spits out. Because of this, it completely fails to capture the magic of unscripted human language, making it highly detectable if you just look past the surface vocabulary and analyze the deep structural dimensions. So, all that panic over total human replacement, it simply isn't supported by the multidimensional data. The myth of this flawless linguistic machine just totally falls apart the second we demand it behave like a real speaker in the real world. Which leaves us with a pretty important question for all you academics, writers, and professionals out there. If artificial intelligence can't even grasp the deepest, most natural variations of human communication, should we really fear it as a replacement? Or should we simply learn to master it as the highly restricted tool that it truly is? Think about that.